Hello everybody, Tony here. Today we're going to be making nitric acid out of potassium nitrate, hydrochloric acid, and copper. So, this experiment is going to be dealing with acids, which are corrosive, and some poisonous gases such as nitrogen dioxide. So make sure you have a well-ventilated area or do this outside. What you are going to need for this experiment is some distilled water, a nitrate salt, hydrochloric acid, copper, and some glassware that will fit together like this. You also need a scale and obviously wear gloves and goggles. The first thing you need to do is measure out around 80 grams of a nitrate salt and dissolve it in around 50 milligrams of water. There's 80 grams. Stir it around a bit. Set that off to the side. Then measure out and add 100 milliliters of hydrochloric acid. Careful not to breathe the fumes, and give that a stir. Now you need to measure out around 30 grams of copper. I'm doing 35 just so I have a little extra. There we go, 35 grams. Now set this copper off to the side. So now you should have your solution, your copper, and your glassware. So now take this outside or in a well-ventilated area away from people, and time to assemble it. Okay, so now that you're outside with your water, copper, and glassware, make sure you put your solution in and then add just enough water to cover the bottom of your container. About another 50 milliliters. Once that's done, you can add your copper. Now that the copper's in solution, a little bit of a stir. Mix everything up. And that's good. So now, place your container over the top. Make sure it's covered so that when the nitrogen dioxide starts being produced, it'll have to bubble through the water in the bottom. And now everything's set up and you just have to wait. So we have our reaction set up, but now it's time to go over some of the chemistry. So you add hydrochloric acid plus potassium nitrate. That reacts to form nitric acid and potassium chloride, but this reaction goes both ways. So you'll end up with sometimes this reaction but it also goes back. So in the end, you'll end up with equal amounts of hydrochloric acid and nitric acid in your solution. So you can't use that on its own unless you want to just dissolve stuff. But what you do then is you add the copper. So the nitric acid dissolves the copper to form copper nitrate and a little bit of water and some nitrogen dioxide. So the nitrogen dioxide bubbles out of your solution into your bigger jar and then is forced to go through the water in the bottom. Which makes a little bit of nitric acid. So that's what you have, but you aren't left over with copper nitrate in the solution at the end. The copper nitrate further reacts with some hydrochloric acid to form copper chloride and some more nitrogen dioxide. From my understanding. So in the end, you end up in your solution with copper chloride and potassium chloride. So these are some of the main things you end up with in the solution. You might also have some acids, like a little bit of nitric left, a little bit of hydrochloric left, but these are some of the main things, and water, of course. And then in your solution in the bowl that you had the nitrogen oxide bubble through, you should end up with still mostly water, but you should have a appreciable amount of nitric acid. So this is the overall chemistry for how I understand it, but yeah. It has been 20 minutes since this was set up, and now you can see the red-brown nitrogen dioxide gas inside, and you can see the solution is turned green and is bubbling. So now is the time you'd want to stay away from it. It will soon begin to bubble through here and some nitrogen dioxide will escape. So just make sure people stay away from it. It's a very interesting gas. Not many of them are red-brown like this. So I think it's cool, but it's now been about an hour after I set this up, and you can see the solution is bubbling pretty good, and it's a lot darker colored. I don't see any bubbling around it. That might be a good sign. It might mean that the water in here is just absorbing the nitrogen dioxide and increasing our yield. So that's good. And there it goes. Now it's bubbling. That's nice. Well, there it is. It's been about an hour and 30 minutes since I started, and now it looks clear. But what I think is in there is nitrogen monoxide, which does this. Now, the water's getting sucked up into it because it's absorbing so fast. That's some neat chemistry for you. I've left it for a few hours, and now let's see. Okay, it's still a little red and angry, but it's all right. I'll try and get the water to absorb most of that. Alright, I try to get it to absorb its best. It's time to take the top off now. There's the nitrogen dioxide. Do not want to breathe this stuff in, as it is toxic. Here's our solution now. It is black and slightly greenish. This water in here should be our nitric acid, and I'll clean up. Here are my two products. This is my crude acid, it'd be nitric acid, and this is my original solution. It is very green, a lot of copper dissolved in there. I will set this off to the side, and sometime in the future, maybe make a video about reprocessing it. That'll be set off to the side. So, with this crude acid right here, has some stuff floating around in it, needs to be filtered. So I'm going to do that. Now that we have our acid filtered, I am going to weigh it, get its density, and figure out what concentration it is. So, yeah. I tried to get a density measurement with this scale, but it wasn't accurate enough, so I'll just show you that it's acid. Okay. Here's a little bit. Here. If it's acid, it should fizz well on something like concrete. Yep. That's acid, all right. The bubbles coming up are carbon dioxide from the carbonates in the concrete. We did it. We made nitric acid from hardware store materials and some nitrates.